Okay, so if we jump into this probability review, given events A and B such that the probability of A is 0.6, B is 0.5, and the union is 0.8, okay, this kind of screams Venn diagram for us. There is event A, and here's event B. We know that the total of what A and B should add up to, or A should add up to, is 0.6. So if I call this X and Y, X plus Y should equal 0.6. B's circle total should be 0.5. So if I throw Z there, Y plus Z should equal 0.5. And the union, so A or B, that would be X plus Y plus Z, should equal 0.8. Now, already, X plus Y and Y plus Z, if I add those together, I get 1.1. I'm already over what the total was supposed to be, which is 0.8, and I'm over by 0.3, which means that's your overlapping part. So this becomes 0.3, and then if I backtrack, A is supposed to add up to a total of 0.6, so I need 0.3 more in here, and B was supposed to add up to a total of 0.5, so I have a 0.2 here. Now the question is determining about independence, okay? First of all, let me review. We shouldn't say dependent. We should just say independent or not independent. So we have to know the formula to calculating that. So you can do one of two things. You can calculate the probability of A and compare it to the probability of A given B. And that's the way I'll do it just because it's the first way I wrote. Now your probability of A is 0.6. Your probability of A given that you're restricted to the B population means out of these 0.5 in the B population, so out of the 0.5, how many of them are also in A? So 0.3 out of 0.5. So you'd get 0.6 equals, and if I do that division, I also get 0.6. So when they are completely equal, that is the definition of being independent. Essentially, the fact that you restricted your audience to the people that were in B did not change their probability of having A happen at all. It was 0.6 alone, and also 0.6 when you restricted it to the B population. So nothing about being in population B made you more or less likely to have A happen. The next example focuses on, again, independence. We're looking at series preference and gender. Are the events student is a male and student prefers a reality series independent of each other or not? Justify your answer. So if you're looking at male and preferring a reality series, we'll call this M and we'll call this R. We would calculate the probability of male and compare that to the probability of a male given your restriction to R. And that's just one option. We also could flip that order. We could look at the probability of R alone and compare it to the probability of R given M. Either way, so half the class could do it this way and half the class could do it this way, and you'll get the same answer. Either they're equal or they're not. So I'll go this way because again it was the first one I wrote down. Probability of being a male, just a male, 230 out of 490. Oops. And your probability of being a male given your restriction of a reality series. So out of all your reality series, out of that 180, how many of those are males? 70. So when I compute these two probabilities, 230 divided by 490, I get 0.47, and I'm checking whether or not it equals 70 divided by 180, which gives me 0.39, and they are not equal, so these are not independent. I don't know what it was, but something about liking a reality series kind of upped your probability, or actually made your probability of being a male go down. So maybe that would go with our gender bias. Who's more likely to watch a reality series? Probably female. So if you are looking just at those people who like reality series, your probability of being a male actually just went down. And similarly, I could do this, and I should get two different numbers. They won't be the same numbers as these by any stretch, but they should still both not be equal. So your probability of liking a reality series is 180 out of 490. And your probability of liking a reality series given that you're a male, so out of all of our males, out of the 230, how many of those 230 like a reality series? 70. And if I compare those, I get 0.37, and compare that to 70 out of 230, 0.30. So again, not equal. So you don't need both sets of calculations, just one or the other, but they both are not equal, so they're both not independent. To interpret this one a little bit more, if I just take our general population and ask what's the probability of liking a reality series, 37% of them like a reality series the best. If I just then look at the males within that population, and I ask all of the males, what are the chances you like a reality series? Now it's down to 30%. So again, we do see that decrease when the male is involved. Okay, number 3, again, we're given some information about an age group, and then the number of text messages sent per month. One thing I will say, this chart does not give us totals, and I noticed that right away. You should really put your own totals, because you're going to need them. So if I add up 4, 37, and 68, I get 109, 6, 25, and 87, I get 118, 25 plus 47 plus 157, I get 229. Those are my totals of within each age group. Now within each text message category, this gives me 35, 37 plus 25 plus 47 gives me 109, and 68 plus 87 plus 157 gives me 312. So when I add all these across, or I add all these down, that should give me my total number of people surveyed. 109 plus 118 plus 229. And just to make sure this is error proof, I should double check that these also add up to 456. And they do. Okay, so now let's tackle the question. If a person from the survey is selected at random, what is the probability that the person texts over 50 messages per month, given that the person is between the ages of 23 and 60? So probability of texting over 50 times, given they're between 23 and 60. So out of all the 23 to 60-year-olds, and there are 229 of them, out of those 229, out of this 229, how many of them are over 50 text messages per month? 157. And there's your answer, 1. Okay, so all of those are conditional probability, Venn diagrams, frequency charts, and the independence. That's the key topic that I think would be on your Regents, almost 99.9% certain. On the back here I have just some spiral questions, just to give you a heads up of what kinds of spiral questions are coming. The first one gives us two functions, a crazy function, a polynomial function, and a second function that's an absolute value function. It wants to know us to state the solutions when h of x will equal k of x. So when will this equal this? Now, we barely, we solve polynomial problems, equations, but not when there's an absolute value in the equation as well, because this side will equal the absolute value side. Also, when the coefficients are fractions, that's a whole other bug we don't want to deal with. Use technology. Nothing says algebraically. So I would just type in these two functions and see where they cross. And you're looking for when 2/9 x cubed plus 8/9 x squared minus 16 over 13x plus 2 equals negative absolute value of 0.7x plus 5. This is the equation that we're trying to solve. We have no clue how to do that algebraically. So I'm going to type this in as equation 1, this in as equation 2, and when I trace and find the intersection, I'm going to get the x-coordinate answer. So y equals, and into my left graph, 2/9 x to the third plus 8/9 x squared minus 16 over 13x plus 2. And my second equation, negative, the absolute value is under the math function, under the number title, absolute value, 0.7x, get out of the absolute value, plus 5. Now zoom 6 will center everything. Here's my polynomial function, and here comes my absolute value. And we're looking for the solutions, plural. There's an S on there. And why? Because it intersects once, twice, 3 times. So we need to find all of those. We'll start with the leftmost. Second trace. Option 5 is intersect. Scroll on your first curve. We're scrolling along the polynomial over to near the point of intersection. Second curve, jumped my cursor to the absolute value, that's the second curve, and then the guess, I just put my cursor near that point of intersection, and that's happening at an x value of negative 5.174853, nearest hundredth, so that's x equals negative 5.17. And we do again, second trace, option 5 intersect, we go over here, enter, enter, enter. X could also equal negative 1.13. Second trace, intersect, and enter, 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 and I get 1.75. And I'm done. That's just technology. I'm going to have to cut this video off because I'm about to hear the bell ring, but I will make a second video for numbers 5, 6, and 7 on this review sheet.